All right, so we're on page 324. We're going to be going through activity 2 and 3, which are solving multi-step equations, continuing from activity 1 on the last video. So it says the substitution method is one strategy to solve a system. When you use this method, you create a new equation with one unknown from the given, and typically we have two equations. In this activity, you'll learn different strategies to solve equations with variables on both sides. Then here it says Teddy and Topher each solved the equation, this right here. Normally I put the line down the equal sign. 5x plus 3 equal to 2x plus 5. So they did it slightly differently. And you notice they did get the same answer of 2/3. Okay, we'll look at what they did differently. All right, let's look at Topher. So he has this equation here. If you can just annotate as I'm annotating here. Remember, you have to get variables on one side, constants on the other. So he probably saw that we have this positive 2x. So he subtracted 2x to both sides. This is equal to 0. So he's doing that to get the variable, no variables on the right side. So it looks like he's trying to get variables on the left side and then constants on the other. Okay, constants, like you remember from last video, is just a number. So when you do subtract 2x from both sides, you do have to simplify here. 5x minus 2x is 3x. We keep this 3 down, right? We copy everything else down that we didn't perform any operation to. So we solve that positive 3 and positive 5. So now we have this equation, 3x plus 3 equal to 5. Since we only have x's on the left, I got to get my constants to the right. This 3, this plus 3, is a constant, so I got to move it to the right. It's adding 3, so I'm going to subtract 3 to both sides. Let's annotate here. That's equal to 0. 5 minus 3 is 2. And at this step, they would have divided 3 to both sides. 2/3 does not simplify, so you can just keep that. Right, x is equal to 2/3. It's fine if it's not a whole number. You might get fractions or decimals. So what Topher did, he got his variables on the left side by first subtracting 2x to both sides. Okay, let's see what Teddy did. Okay, so same equation. And then you probably saw that we have this positive, I'll put plus, 5x on the left side. He decided to subtract 5x to both sides. So he's going the other way. He's wanting to get variables on the right instead of the left, and now constants, numbers, to the left. Okay, well, we copy down this 3. 2x minus 5x is negative 3x. And then you're also just bringing down this positive 5. Okay, so at this step, we have variables. We have all our x's on the right. We've got to move our numbers and constants to the left. So we have a positive 5. We'll subtract 5 to both sides. This is equal to 0, and 3 minus 5 is negative 2. So we're at this step. Negative 2 is equal to negative 3x. So to get rid of this negative 3, it's multiplying. I'll put a dot in between. So divide both sides by negative 3. Right here, it cancels out. A negative divided by a negative is a positive, and it's just a positive 2/3. Right? But you could write 2/3 is equal to x. That means the same thing as x is equal to 2/3. So as you can see here, right, we do have the same answer in both. Let's just put this into writing. How were the solutions strategies the same, and how are they different? They still performed inverse operations to both sides. I'll put OP to both sides. Right, inverse means opposite. But one strategy is, Topher decided to, we'll just say Topher got variables, or I should probably put moved variables. Moved variables to the left. Let's say left. And Teddy decided to move variables to the right. So notice how right? It actually does not matter. The answer is still the same in the end, right? As long as you're performing the correct inverse operation to both sides. Which strategy do you prefer? I'll leave this to you. Okay. For me, I probably prefer Topher strategy just because I don't have any negatives in my answer, right? I'm not dividing by a -3, I'm dividing by a +3. Whereas, right, Teddy did have a negative, right? These were initially negative here. But all in all, besides that, it's all the same to me. Okay. All right, let's move on to the next page, 325. Okay, so we're going to practice solving some of these. So we have, it's just saying solve each equation. Choose why you chose the solution strategy that you used. So I'll work on the one on the left. Let's say the one on the right is a U-do. Okay. Now, before I begin, let's put a 1 in front of this x. And you can move your variables to either side. I'm going to move my variable, I'll put my variable to the right and my constants to the left. Okay. So since I want my variables to the right, I already have this 5x on the right, but this 1x is not there. Okay, so I got to move that there. It's a positive 1x. So then you ask yourself, what's the opposite of that? I'm going to subtract 1x to both sides, and I'll write it underneath this 5x because that's a like term with it. They both have x's. Okay. I normally put an equal sign and I rewrite everything. I rewrite this -6. I'll simplify 5x minus 1x is 4x. And I copy down this +10. All right, so great. I've got x's on the right. Now let's move all my numbers to the left. All right, so in this case, this is a two-step equation. This +10, or it's got to be on the left, so I'm going to subtract 10 to both sides. Right, and just like how I circled for the x, I'm going to circle this. That's equal to 0. -6 minus 10, right, same signs. You add and keep the sign. So add, 6 plus 10 is 16. Keep the sign, they're both negative, so I keep it as -16. And that's equal to 4x. Now here, it's always, if we have a coefficient like this 4, it's multiplying. So the opposite of multiplying by 4 is dividing both sides by 4. Okay, well, 4 divided by 4 is 1. 1x is the same thing as x. And on the left side, right, negative divided by positive is a negative, and 16 divided by 4 is 4. Or you can write it like this. Some students prefer to write it like this, where the variable's on the left. You could also write it like that. But just so you know, right, either way of writing it is exactly the same thing. We're saying that the x is equal to -4 in any way, despite the location of it. Okay. So in this case, we subtracted x to both sides. Okay. So I'll leave it for you to try to figure out where do you want to move your variables to, and then try to solve this one. And let me know so I can check and give you some feedback on it. Okay. So we're going to answer numbers 3 and 4 by looking at these two situations that Sandy and Sarah did. Now, my first disclaimer here is, well, I'll actually write it in here, but let's put a star. So you can do anything to an equation. So we'll say you can do anything to an equation. Or sorry, to an equation. All right, we're gonna put comma, but, right, the only thing that you can do anything to an equation as long as you do it to, what does it say, but perform to both sides. As long as you do it to both sides of the equal sign, it works. So let's look at Sandy and Sarah's situation. They do have two different equations. But let's look at what they did. Okay, line by line, because it's a lot when you look at it all. So Sandy had this equation. 3x plus 9 equal to 6x minus 30. Now what she decided to do, she rewrote the same equation. She decided to divide everything by 3. Now she saw this because every single one of these numbers, the 3x, the 9, the 6x, and the negative 30, they're all divisible by 3. So you can divide everything by 3, and what's the purpose of doing that? Is because if you divide everything by 3, now you have an equation where we have smaller numbers. And I like to deal with smaller numbers. The bigger the numbers are, maybe the more mistakes I make. Okay, but from there, right, she subtracted x to both sides, which we know this is a 1. And then from there, she saw that we have this minus 10, so let's add 10 to both sides. 3 plus 10 is 13, 13 equal to x, we're done there. And you can also write it the other way, x equal to 13, okay. All right, we're gonna answer number 3, which is compare and contrast Sandy and Sarah and their strategies, but let's talk about Sarah's strategy, okay. So what does she do? Okay, so Sarah has this. Negative x or negative 1x, if you want to write it like that, minus 2 equal to negative 4x minus 1. So what do you notice in all of these terms here? Right, she rewrote it, but then divided everything by negative 1. So what's the purpose of that? Okay, let's divide by negative 1. Now, every single one of these terms are negative. And when you divide by a negative 1, what does that do? We get this equation. It changes everything to be positive because we know a negative divided by a negative is a positive. Actually, let's put that there. Negative divided by a negative is a positive. Okay. And I'd like to solve an equation where we have just positive numbers. I think that's probably easier to deal with. So that's what she decided to do. She subtracted x to both sides. Right, again, this is a 1x. Where we copy down this 2, copy down this plus 1, and then 4x minus 1x is 3x. Okay. And then we have this equation, 2 equal to 3x plus 1. Well, at this step, she got her variables on the right. We move constants to the left, so we subtract 1. And then we have 1 equal to 3x. If you divide both sides by 3, right, this cancels out. Right, this is equal to 1. And 1 divided by 3 doesn't simplify. We just keep it. It's 1/3. 1/3 equal to x, or, right, x equal to 1/3. Okay. All right. So let's go into compare and contrast here. What Sandy decided to do, sorry about that, is divide by 3. Right. Notice that everything was divisible by 3. And then Sarah decided to... is divided by there, decided to, let's cross that out. Sarah divided by negative 1. Right, she did this, actually I'll put comma, so that all terms are positive. Okay. So, you can go through varying strategies that way. I'm actually going to go through B. I'll have you do A as a you do. Okay. Now I'll give you a hint for A though. Notice how, right, we have negative 4x plus 8 equal to 2x plus 10. All these numbers are even. So maybe you can do something there to make it a little bit easier. Maybe you can divide something. So think about what number can go into all even numbers. But for my problem here, for number 4b, I see that we have everything is negative. So why don't I divide everything by negative 1 to make it all positive? Right, negative 4x divided by negative 1, 42x, it's a positive 42x. Negative 4x divided by negative 1 is a positive 4x. And negative 1 divided by negative 1 is positive 1. Okay, I like to deal with that a lot better than this negative. So let's move variables onto one side, constants on the other. Now I see that this constant is the only constant we have is positive 1. That's on the right side. So why don't we just say constants on the right, variables on the left. Okay, so I see that we have this positive 4x on the right. So let's move it to the left. It's a positive, so I'll subtract 4x to both sides. Okay, this equals 0. 42 minus 4 is 38x equal to, you can put plus 1, but I'll just put 1. And then at this step, right, you can divide both sides by our coefficient. We're multiplying by 38. So your final answer would be x equal to, it is a fraction, x equal to 1 over 38th or 1/38. Okay. All right. So that's going to conclude activity 2. We're going to go into activity 3, which is requiring our understanding of right, solving an equation algebraically like we did here, but it is the substitution method. So we're on page 326. Okay. So we're going to highlight some things. We'll write some equations, but let's look at the context here. It says Janet helps her mother make potato salad for a county fair and goes to the market to buy fresh potatoes and onions. The sweet potatoes cost $1.25 per pound, and potatoes cost $1.05 per pound. Okay, her mother told her to use $30. To use $30 she gave her to buy these two items. Okay, so in this case, we're not going to use slope-intercept form because we don't have an initial value and a rate of change, right? This is more of a standard form, ax plus by equal to c, because we have two things and then a total. Number 1, write an equation standard form that relates the number of pounds of potatoes and the number of pounds of onions that Janet can buy for $30. Use x for onions and y for potatoes. Okay, so x is onions. So the thing that was related to onions is this 1.25. So this will be 1.25x for onions. Plus, instead of by, it'll be 1.05y. And then the total thing costs, or we're using up $30. Okay, right, that's a 30. All right. Number 2, Janet's mother told her that the number of pounds of potatoes should be 8 times the number of pounds of onions in the salad. So we want more potatoes, right, compared to onions. Otherwise, it's going to be like really oniony. Write an equation in terms of that. So this is a rate. That's y equal to 8x. Right, so we want, right, x, which is onions. If you multiply by 8, it equals y, which is potatoes. Okay, and then number 3, it says, will 1 pound of onions and 1 pound of potatoes satisfy both equations? Okay, because if 1 times 8 is 8, so that works out for this one, right? But it doesn't work out for the first equation, right? So that gives the coordinate of 1 comma 8, so this is no. Right, if you substitute, you will get a false statement instead of a true statement. Right, if you substitute 1/8 into false statement for the first equation. Okay. Right, because if you put 1 right here, right, 1.25 times 1 is 1.25. 8 times 1.05, that would be $8.40. $1.25 plus $8.40, that does not equal $30. So that's not going to work out. Okay, so there's another way that we can go about this, and that is the title of the lesson, which is, right, activity, which is the substitution method. Okay, so let's go through it step by step, the worked example. So we have these two equations here. The first step is to use the substitution method, begin by choosing one equation and isolating one variable. And then you consider this the first equation. So because y is equal to 8x is in slope-intercept form, this is the first equation. This is what we call the solved equation because we have a variable equal to a bunch of stuff. Okay, we'll substitute this, but we'll look at step 2 actually. Now substitute this expression equal to the isolated variable into the second equation. So we're going to substitute this 8x because it's equal to y right here wherever we see y in the other equation. So notice how I'm replacing y with 8x. Okay. So with this, right, you can solve this equation. If we plug it in, if you multiply, right, like I said, 1.05 times 8x, it's $8.40. And these two things are like terms here, right? If you combine this, $1.25 plus 840, that's 9 and 65 hundredths x equal to 30. Now how we got this answer, you can use a calculator, but we divided both sides by the coefficient of 9.65. Okay. Now this gives us one part, right? This gives us x, and x is what we said is onions. So this is 3.1 pounds of onions. Now we need to find y because we know that our answer is always in terms of x comma y because it's two values, right, for both these equations. So what you do to find y is you substitute the value of y into, x into y equal to 8x. So this 3.1 goes here for x. And if you multiply that, or you can use a calculator or just multiply it freehand, it is 24.8. So this means it's 24 and 8/10 of a pound of potatoes. So this does give us our answer. We can check our answer. How you would check your answer is you would plug in into the original equation. I'll put 3.1 for x. I'll put 8.8 for y. Now we did have to estimate here. Actually, so instead of putting equal to, we did have to estimate for x. We'll put approximately equal to 30. So I like for you to try to simplify the left side. If you multiply, right, these two numbers and add that after you multiply these two numbers, you should get something very close to 30. Okay. But also the other equation, y equal to 8x, right, that is 24.8 equal to 8x, right? 8 times x was 3.1. Oops, another approximately equal to. Simplify that, and you should get something very close to each other. Okay. All right, but let's move on to page 238. Last page that we'll work on before activity 4, but that's for next video. What is the solution to the system? The solution as an ordered pair, since it's x comma y, is 3.1 comma 24.8. What does it represent? Right, this is pounds of onions, and this is pounds of potatoes. Okay. All right, and then number 6. You're welcome to complete this for a you do there, but we're gonna end it there. All right, let me know if you have any questions.